नमस्कार। This is Professor S.LAL, Professor of Mathematics and Computing. The Department of Science and Technology under the Faculty of Education and Methodology, ज्योति विद्यापीठ, वुमेन्स यूनिवर्सिटी, जयपुर। कैसे हैं आप लोग? How you all are? Please. Today, I am delighted to share one of the most important topic of your GATE competitive examination, and I hope you are aware about the syllabus of GATE. If you are a student of computer science engineering, if you are a student of electronics and communication, EE, civil, instrumentation engineering, production, textile, and whatever may be the stream of the engineering, you know that the gate pass goes to the counter of mathematical portion of your gate examination. And in that circumstance, it is very necessary for you to understand that how to tackle gate examination. In my previous lecture, on the same platform where I am discussing today, I discussed about topology, some important questions, some important part of topology. That is also part of MSc Mathematics, MSc Computer Science. And the one thing that is very, very important for you, because in your engineering, in your all 4-year syllabus of BTech, generally in so many institutions, in so many universities, functional analysis has not been a part of your study, but it is part of your GATE syllabus. So, it is important for you to check yourself that how you can prepare for GATE examination. So, topology is important aspect. In the like scenario, your functional analysis is also important. So, in functional analysis, I would like to discuss today one of the best and one of the most important chapter. Please let us write the topic I am going to discuss from functional analysis. So, the students, The topic today I will be discussing, that is Banach spaces. Please write, please write Banach, DNA, DNA, CH spaces. You can see this topic. This is Banach spaces. This is the topic, Banach spaces in your functional analysis. We shall be discussing about Banach spaces, and as per my experience, as per my expertise on this subject, on this course, I honestly can say you that if you have knowledge of this chapter in functional analysis, then it is possible for you to tackle some question of this part. So, my target is to give you some selected questions. I will give you questions. Questions for date, for examination. Meanwhile, my target is also to divide the basic concept of visual and the basics of the building and fundamentals. So, students, I hope you know what is Banach spaces. So, here let us recall linear spaces. Linear spaces. Linear spaces is what? What do you mean by linear space? I ask you that tell me something about linear space. Then you should write this. You are not anything regarding that you write that linear space. Please write linear space is an order triple, and that is F. Linear space is an order triple. See the order triple. I hope you are saying this is order triple. This is the symbol of order triple. L in between like dot sign and then capital F. So please write where capital L is an additive abelian group. Where capital L is an additive abelian group, comma, I am defining that what is L, what is F, and what is dot. So you write, please, for L you write, L is an additive abelian group, comma, capital F is a field, capital F is a field, and dot is a function. Dot is a function from F cross capital L into L. F cross L. I have written here. F cross L. This is F cross L. F cross L into L. F cross L into L. L. Whose value at right in the form of coordinate alpha x, whose value at alpha x is denoted by alpha x such that such that such that for alpha beta belongs to F, alpha beta belongs to F, capital F, and xy belongs to capital L. We have, please write firstly what you have written. These are the symbols you are using here. You can see. You can see. You have written alpha x, then alpha x such that alpha beta belongs to F, and xy belongs to capital L. You have written you have already listened, but whether you have written or not, so I am showing it, why I am showing all these things to you, so that it may be visible to you. Then you know the first condition is what? You know the first condition? What is the first condition for that? For that, first condition is alpha into x plus y is equal to alpha x into alpha y. Second is alpha plus beta into x is equal to alpha x into beta x. And the third is alpha into beta x is equal to alpha beta into x. It means for linear space, you have to satisfy the three postulates and see what are the three postulates. The first postulate is, see, this is the first postulate. Here, the first postulate alpha into x plus y is equal to alpha x into alpha y. The second postulate is alpha plus beta into x is equal to alpha x into beta x. And the third postulate is what? Third postulate alpha into under bracket beta into x is equal to alpha beta into x. So these are the three postulates. If these three postulates are satisfied, then you can find a linear space. And please write here, it is very much important. Please write, it is important to note that linear space is completely an algebraic structure. This is the part of your MCQ, that whether linear space is a algebraic structure or symmetrical structure or optimized structure, or what type of structure is this. So, and one thing that is very much important here, a linear space will be called a linear space. A linear space will be called a real linear space or a complex linear space. According scalars are real or complex numbers. Note it, your linear space will be called real. Note it, your, what I want to say? I want to say that your linear space will be called a real space if the constant, if the scalars existing are real, and if the linear space scalars existing are complex, then your that linear space is complex space. So I can give a live example. Your family is recognized as per the academic standard, as per the post, as per the jobs, as per the designations of your family members. If there are 3 IAS, 3 GATE qualified, 3 corporate jets in your family, that people say that this family is a very high-five family, in the sense of education, in the sense of technical education. So linear space is the linear space, but if the scalars that is going to be used in your 3 postulates that I have written 1, 2, 3, if these 3 postulates you are saying that there are some constants and there are some variables. If the constants you are taking are a scalar, sorry, real, the constant, suppose alpha is constant, then your linear space is what? That is real linear space. And if constant is complex, imaginary, then your this space is called complex linear space. Also, we shall use the term linear space whenever our result holds both for real and complex linear spaces. So if you are saying linear space, it may be real space or it may be a complex space. It is important for everyone to remember that what is the real space and what is the complex space. Now students, I hope that you have got it, that what is that what is that what is that what is linear space. Now, to understand the Banach spaces, we have to understand another term also, and that is also a defined terminology, that is normed linear spaces. Normed linear normed linear spaces. This is also defined terminology. So knowing linear space, then knowing normed linear space is tending toward the point that is called Banach spaces. So I'm not directly reaching on the point Banach spaces. Firstly, I have discussed primarily the concept of linear spaces. Then I'm going to discuss normed linear spaces. So let us write firstly the definition. I hope that you have written this stuff. Normed linear spaces. Students, it is visible. Normed linear spaces. Yes, this is the topic we are going to discuss today in this session. So let me allow to define that what is normed linear spaces in a very short and a very concise form. I would like to explain this. So please start writing. If you are unable to write, then you can see my video later on and you can write. So please listen at least what I am telling you. Let capital N be a complex or real linear space. Let capital N be a complex or real linear space. Means capital N is a linear space. As per the nature of the constant, it may be complex or it may be real. You know well. And let there are widely used symbols. I hope you are seeing this. Two vertical lines in left and two vertical lines in right. Here, this. I hope you are seeing this. These lines, these two vertical lines in left and two vertical lines in right. This. So this is read as, this vertical line is read as norm of. This is read as norm of. So please write. Again, I am repeating, let capital N be a complex or a real linear space, and let norm of be a function of capital N to capital R, such that capital N to capital R, such that for all xy belongs to N, for all small x, small y belongs to capital N, for all xy belongs to N, and for all xy belongs to N, and for all alpha belongs to C, or R. See here xy belongs to N. See, for all xy belongs to R, for all xy belongs to N, means x and y are member of natural number, And for our alpha belongs to complex number or real number, then it is right. Then we have very very important. Then we have n1. Please write n1 such that norms of x is greater than or equal to 0. N2 such that norms of x is equal to 0. N3 such that norms of x plus y less than or equal to norms of x plus norms of y, and N4 such that alpha into x, norm of alpha into x is equal to norms of alpha into norms of x. Students, these are the, you can say, your key of success. That what are the four conditions to form a non-linear space, and your career is beautiful to you. It is your career. So write first n1 such that norms of x is greater than or equal to 0. This is the first. And I hope you are looking second and 2 such that norms of x is equal to 0. And the third you are also observing, not n3 means norms 3 such that x plus y, norms of x plus y less than or equal to norm of x plus norms of y. The last is n4, that is norm of alpha into x is equal to norms of alpha into norms of x. These are the four postulates. These are the four postulates. These are the four postulates to form non-linear what spaces. So after writing these all, let us write the below line. Then the function, two vertical lines from both sides, two in left and two in right, right? Please write then the function norm is called a norm on capital N. It's called a norm on capital N, and the pair and the pair and the pair and the pair N capital N and norms, and the pair this and the pair N comma norm in the first bracket. Right, please. It's called a complex or real norm. It's called a complex or real normed linear space. So one thing I would like to ask, that here you are saying play of three different, you can say, yes, in the beginning you have taken, but how many, you can say, players are in your this game? Try to understand. This is a game. Suppose normed linear space is a game in which capital N or capital C means either Dhoni or Kohli. Either of them is the captain as per the nature of the match. So N is the natural number, that is real, and C is complex number, that is also a number, you know well. And you have X, Y. X and Y, these are the member of what? These are the member of capital N. And alpha, that is the member of complex, or that is the member of real. But alpha is not member of N. Alpha is either complex or real. There is difference between real number and natural number. You know, rational number is also a real number. Negative number is also a rational number, or it is also a real number. 2, 3 by 2 is also a real number. But natural number is what? It starts from 1 to 1 and tends to infinity. So in N, capital N, there are two players, they are X and Y. And in capital C, there is one player, that is alpha, and that is, you can say, of the obvious nature. This may be, you can say, member of C, or this may be member of, right, R. They see you can understand that not complex, and that we don't. That we not see in China or Russia. I was in 1 and 1 and 2 and 3 and 4. You see, in 1, you are talking about related to Captain Tony M. And in all four conditions, you are not discussing. In the last condition you are discussing about L a little bit, but the first three condition is about X and Y. So first is what? You know, norm value of X is greater than or equal to 0. Yeah, and the second, that may be that its norm value is equal to 0. Third is that the norm value in composite form of X plus Y, it may be less than or equal to, by the, you can say, study of inequalities in your junior study, in your junior classes, you understand that X plus Y modulus value is less than modulus of X plus less than plus modulus of Y. The like scenario is here. And the mentionable is N4, that is alpha into X, the norm value is 10. Here again, alpha is showing its nature. Alpha is being separated from, you can say, X, and there is norms. There is norm of alpha and there is norm of X. So these are the four conditions. And here you, in your UG level mathematics, there was a topic group in which, remember, there was a non-empty set G and there was a binary operation O. Then G comma O, both were forming a group under some postulates. As remember, existence of closure law, associative law, existence of identity, existence of inverse. Then you are saying that what then E and O are satisfying all four postulates, so they form a group. Here, capital N and norms, when both are taken together, then they form a non-linear space. Here, in your linear space, norm is also included. So the name is non-linear space. You know, in mathematics and computing, without practice, without doing, just by listening, it is not feasible for any scholar or for any expert to make it clear or to understand what the things are happening for you. So I suggest you that what you have written, you should try to bring this in your exercise mode, and then you should only be capable to execute or to reproduce or to remember. So I hope written this very little bit about this also. This right here the property entity is called, you have written N1 and 2 and 3 and 4. Here the property entity is called sub-additivity. Right? Sub-SUV, sub-additivity, and DI, DI, sub-additivity, and 3 is called sub-additivity, and N4, condition N4 is called absolute homogeneity. Here, we have to execute the condition of non-linear space. N3 gives the definition of that. N4 gives the definition of what? Which is right. N3 gives the relativity, and N4 gives absolute homogeneity. Then we teach our students, other students, that or architect, or even great aspirants of our STEM university, Gopi University. Then we specify all these facts to the students, that what you have to do, how you have to, you can say, classify your definition. You can create 4 and 5 smaller definition, smaller corollary from a particular existing concept or definition. So you should also adopt this, because I am teaching you, knowing that you are also my student. Whether you are in India or whether you are in abroad is not a matter. Matter is that you should learn. And I assure you that if you are more comfortable in topology, and when you are more comfortable in functional analysis, then you are more comfortable in your gate examination. I can challenge. I have given so many results in gate examination in between 96 to 2015. So again, I am planning to do something for our students. So now the next topic, that is the, you can say, topic of our today's discussion. Please write Banach spaces, BNACH. SPACES, Panac Spaces. Just in one line, I will just read this definition and I will let it for you to think that the topic we have discussed, the two topics we have discussed, is going to help you in your this topic understanding or not. So please, I'm just reading that definition by the standard material. Please, you can write also a normed linear space. A norm, I'm defining, but please tell me, I'm defining Banach spaces. Whenever we visit anywhere in India or in abroad, scholars start to discuss something. So please say something about spaces, norm spaces, linear spaces. You are fortunate that you are listening free of cost. But this power, this lecture is powered by this university for you. So be happy and listen. A non-linear space which is completely as a metric space. A non-linear space which is completely a metric space. So now you can say, sir, what is metric space? I don't know. If you don't know, then you should write in the comment. Then in the next class, I will discuss about metric space. A non-linear space which is completely a metric space is called Banach spaces or simply a P space. A non-linear space which is, there is a non-linear space, right? Till this moment, till this part you are clear that what is non-linear space. Now if this non-linear space, it is clear that you are intelligent student, then think what will happen if you qualify your GATE examination. Then either you will be doing MTech or you will be posted in some government of India ventures like Nor company in Hindi, you know where, or you may be posted in some other corporates. So a non-linear space which is completely a metric space, you have taken a non-linear space, and if that non-linear space is again a metric space also, a non-linear space which is completely a metric space also, intelligent as well as get qualified, a normed linear space as well as a normed linear space which is completely a metric space is called a Banach space or simply a P space. So I would like to give a suggestion that if you are not recalling that what is metric space, you should recall and you should revise that. Otherwise, write in the comment box and shall try to explain this. Thank you very much, students. I'm going to complete 45 minutes in this lecture. Thank you very much. You have listened me. I hope this lecture is going to be fruitful. This lecture is going to prove the fruitful one. And you are going to now start with this chapter on your own ability, and you'll be doing something from this chapter. Wait for the next lecture. Again, whenever I will free from my the responsibility of the university, then I will be before you to discuss on the same platform. Thank you very much. Namaskar. Dhanyavad.